right, let's see how this works. Looks like my audio is coming in. I can almost see myself coming online. Beautiful, 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 beautiful. Okay, so today what I'm working on is over here. This is is circle packing chart. So its primary use is displaying the relationship between categorical data. So you can see each of these circles is going to be kind of their own category, and you can see how easily it's been kind of split across each of these different areas to create something that can really show you what the whole of the category is. So this is a really interesting chart that I'm trying to make in Power BI. So, made quite a bit of progress off stream, but I mean, just a little bit more work to go. So, that's what I'm going to be doing today. And if you notice there's a change in compression rate or literally anything, it's because I'm using NDI right now, which if we go over to here, effectively means I've got one computer, two computers. We've got the cloud over here. So the one computer where I'm programming and we've kind of got a network. So I'm sending the frames over to this other streaming computer from my programming computer. And so that's kind of offloading the task of compressing the data and also giving a little bit more latency to the stream through just the ability to not have to process every single frame on the same computer I'm currently running all the code on. So that's being sent over to there. It's also giving it a little bit more flexibility, what with dropped frames and all that stuff, because it can kind of collect the frames through NDI. And NDI is just a really neat protocol that allows you to kind of build your entire, turn your network into a audio device. So NDI. So that's how that's being sent over to the streaming computer, and then it's the streaming computer that's sending it up there. So like, if there's anything weird going on, feel free to just let me know. All right, so back over to here. So far, VS Code. So far, what we are doing is quite simple, except for this thing over here. But this is effectively just taking the data model passed in to Power BI, which looks a little bit something like, should look a little bit something like this one because it's categorical. So it sends in data, not exactly as that. Oh, okay. So it sends in the data as a go into here as a data view right here, which it's always the 0th data view. Do not ask me why. Data view is 0. I'm guessing if I had to take a guess as to why, I'd probably say that they wanted to implement the ability to use multiple data views, but just never got around to it. However, it could also be legacy stuff. So over here, we have our data view. And this is effectively one of 5 kinds of data views. You got your category, matrix, metadata, single, table, and then tree, but tree is completely undocumented, so I'm guessing it's just an artifact. And so then we go over into categorical, and we can see if we'll also open up this table. Here's the data I'm kind of passing into it right now, just as an example. So we've got sector, country, company, number of GPUs, because that's what this is visualizing. So we got our 4 categories. This will be the first one in the hierarchy. And that's really what I want to highlight in this visual, how to use hierarchical data to actually create hierarchical visualizations and show people how you can do something like that. So go into here, you've got 4 categories, and each of these categories is going to, well, not this one exactly, but we can go into first category, and we can see the values. So you got 4 categories because you got sector, country, company, and number of GPUs in our hierarchy. And I'll show you this over here. So sector hierarchy, uh, it's got the 4 different values in it. And so then we can keep moving down. So first level is going to be private, public, or national health, or national HPC. Second is going to be the country, so US, 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 FR, D, US, US. Then other one, this is going to be company, and this is helpfully in quite a hierarchical order, so it's not that difficult to parse. And then the last one is going to be the values assigned to it. And then we've also got, other than categories, we've got this values array, which also displays the values that are available. So it's effectively a tree, but in a really weird format. And so what I was able to go and do was take all this data and move it into a D3 abstraction of a root, which is the hierarchy. So you've got kind of the same thing. So you've got root with 3 children. These will be uh, private cloud. So you've got your first one, uh, public cloud, HPC, and then you can delve even deeper into this. So we go into private public cloud, check out the children of that, and then you can see that because public cloud only has US companies, it's only going to be one value, which is US. And then you can go check out all the children. You've got Lambda, you've got Oracle, all that fun stuff. And so, I should note this over here. So effectively what it's doing is it's taking this categorical data and moving it into a tree in this general format. And once we've got this tree, what we can do is rearrange the tree a little bit so it becomes this circle packing. And so that is exactly what this function does. So it takes that root node that we provided it and it iterates through all of the children nodes, and then it creates adds the additional information to the objects, because that's how D3 works. It takes additional information and it modifies or it mutates the original values you pass into it. So it mutates the original hierarchy to include all the information that would be required to build a pack chart. And so it'll most likely do the same thing for any other kind of chart as well. So it just mutates the array. But as you can see here, this is not a JavaScript file. This is a TypeScript file. And TypeScript does not like mutating values without knowing exactly what is being mutated. So that's kind of been my struggle for the last couple days. But I managed to get this working, mostly. As you can see, however, there's still it still looks a little bit different from this one, just a little bit. So I'm gonna spend this stream trying to figure out what exactly has gone wrong with this thing. And so the easiest way to look at that right now is to go into our selection. And so this is effectively what this can be lined up to is when we start off the visualization, when we construct the thing that all the visuals go onto, we are appending a few different things at startup, including this G section. And this G also has a class node plus this ID, just to make sure that we don't accidentally modify that if we select all for this G element, we don't accidentally modify everything in multiple visuals if we had multiple in the same page. So I can go over and copy this. If it's willing to be copied. Anyway, you get the idea. I can make two of these, but modifying one will not change the other chart because we have that unique ID attached to it. And so we first added a G, which in SVG is a grouping, with node dash this ID. So this is a grouping for all of our nodes. And then we're also storing this inside a variable just for additional safety. Safety in the sense of TypeScript safety, but it makes it easier to access in the future. And then what we're doing is we are taking the results of this d3.pack, which will be the same root, but with the additional elements added onto it. So like -r and all that stuff. So taking the same stuff, root with -r, r in this case being radius, as you can see here. I'm gonna have to change this. This was some old code, but effectively it'll take the root and then join all of the descendants from, so it'll take this root node, it'll take all the things on the node we just created, so all of the elements in this thing, and then it will select all of the A elements inside of that element. So we can go over to our actual browser and check this out, because, so you can see here, we are still in the SVG. So originally, when it starts out, it doesn't have any A elements attached to it. But because we have a select there, select all, and then we join it, or we attach the data from descendants, which is this, which just means because we're getting the root and then all of the descendants, it's effectively everything other than just the default root. So what we can go do here, we get those descendants and then we join it with all the A's, which is what produces the actual A's here. So we've gotten all of these A's created for every data element in that array of descendants, because that's kind of the framework, or the, what's it called? That is the paradigm that D3 takes for making these visuals. And so then after that, what it does is it takes elements from that data we passed in, which is the descendants array. So for each element in that descendants array, it's going to perform something on it to get the ID. In this case, we are saying ID, or for each descendant, for each of these A elements, the attribute ID is going to be descendant, the current descendant associated with that A element, .data.name, which is, if you look over here, you can see that ID, private cloud, public cloud, all this stuff. So you can see that these do match up very well to all of the nodes inside of our tree. So that is what we are expecting. So I think that the best way to kind of troubleshoot this right now is to figure out exactly which nodes aren't generating in the center here, because ideally we'd have these generate in the center of the visualization, or inside various different areas of the visualization, much like this. And that's just translating it by the x and y value provided by that packing function. And so once we figure out exactly why all these ones are breaking, we'll be able to figure out how to fix it. So that's interesting. So we've got a subelement in this G, which is this A, and then this A has a lot of different circles added to it without any real reason why. And it looks like these are all actually the center circles, all translated by 0. Well, not all of them translated by 0, 0, but a lot of them translated by 0, 0. And so Wondering what that's all about. Oh, okay. And it's kind of done the same thing everywhere. Weird. Okay. So that's probably because I did do a secondary data join here. Yeah, that'll be it. So I should be able to just go into here and append circle. But the thing I've found in the past with appending circles like this is that it just doesn't, it tends to make it so that when we select the D3 circles, so in theory, what happens once we're done with this, or once we don't want this, or once we remove all of the data from this descendants array, which will mean removing all the data from the original array that's passed in, we have to, it'll select this, see that there's no data in it, and create and replace the existing circles with 0 circles. But in my experience, what happens when we have append to it, it kind of still thinks those A's should exist because they've had a circle appended to it and doesn't delete them properly. So we'll just have to see exactly what happens. So it looks like we've got nothing here, but that could very well be deceiving. So we want to go back over to this SVG and see we've got all of our A elements, and these are all packed slightly tight or together, and it looks like they're creating the general outline of what of the shape we are looking for. So we'll have to go into here, root, and it does create a circle. Interesting. Stroke opacity, transform. Give us a second. Yeah, that just don't make sense. Node.js runtime. And I've got like 1,000,001 browsers open, so that also checks out. Good grief. Sorry about that. CPU is only at 25%, but fans running full tilt. Weird. Weird, 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 weird. Okay, so we've got a circle here, but the circle isn't actually circling. R equals 15. Open this one, and all of these R's do look to be equal to 15. Okay. Can't say that makes sense, but I almost get it, especially if we're still using this code. So dr, because this is TypeScript and it works really weirdly with the provided D3, what we have to do is we have to create an object to hold this, to hold each of these nodes inside, and then add in the classes into here. So that's how it will know, and then we've got to kind of tell it explicitly to use it as this. Does not exist on hierarchy node, node datum, but we can tell it to pass it in as node datum. Okay, so d dot this shouldn't be. This should only be one node per thing. That's what we're able to do. Oh, because it's one level in the hierarchy. Oh. Well, that kind of sucks because that means that... So let's go back into this root and print this out, just so I can show you that so the R is present on here. However, it's not loading up with data properly, which is weird. Depth 0. I'm guessing this might be something to do with the depth and the height values. That is kind of my guess at the moment, but it could also be just the fact that these things... Yeah, okay. Okay. So we're setting the value for these objects, but we aren't actually setting the value for the nodes in the hierarchy. So that is probably why the sizing is so whacked right now. So what we are going to have to go do, next.data.value, we might be able to say, but I think that the difficult bit is going to be that d.r. So we'll just go back to saying this is 15 for now. It's going to make it look weird, but it should work. So we can go back to here. All right, so there we are. That is sort of kind of a little bit what we are looking for, just in the far right corner of the screen. And so then we've got X, Y, and then we can go check this out to get a kind of view of this thing, but it does look like, talking about it from perspective, like you can see here that this node, which is HPC, which you can see is only really Princeton, it's much smaller than the other two nodes, which would require all this. So it is displaying a proper hierarchy, which is awesome. Which is awesome. So now we just have to get it to A, translate, B, read these R values correctly. Which is maybe a little bit harder than I originally thought. The primary difficulty being I could re-implement a class that implements this H3 hierarchy interface. Hierarchy, let's go over here. So I could easily, well, I could go in and create a hierarchy that re-implements this. And I'll go show you the source code for this stuff. So it's got kind of hierarchy. Do we have descendants, leaves, iterated sorts? Yeah. Export hierarchy. So this is the one that, yeah, here we are. Perfect. So, oh yeah, because that's the original JavaScript version. Okay, so I could just re-implement a class that implements this hierarchy node, datum, over here. Data, datum, all this kind of stuff. That wouldn't be that difficult, except for all these functions down here. So this ancestors, this descendants, this leaves. Because it's TypeScript, there's kind of a gap between where the D3 lives over here. So it could go back into here, and you can see all these functions. So these in JavaScript are implemented in the actual, in here, not even in here, in hierarchy. It'd be implemented somewhere in this general idea of a class, but because something, maybe not explicitly TypeScript, but I'm guessing something to do with that, these functions are now kind of built in with this code. So I'd have to go through and re-implement all these functions. Should not be fun. Especially if I wanted to get just to modify this one value, which is R, which obviously doesn't exist on here, so it's not going to be in here. I wonder. Yeah. So this would be missing all of those default things, which is like, I'm guessing there's some sort of super in TypeScript. That was the wrong button to press. Okay. Well, let's see this working. And of course, obvious skill issues on my part, but for not knowing how to do this, but no, so this is all implemented inside a constructor. Let's try that. If they don't have implementation or runtime behavior, how is the function those, you know what? D3 dot, this is going to be, so I should theoretically be able to call these functions stored inside of here on here, maybe? no explored members named hierarchy node. Modules types. Well, the thing is, it's right there, dingus. Count as, but a better type can be inferred from usage. Okay. I think I see what I'm getting at. So if we take ancestors, something like this, we could say, let's first get these ones implemented because that's going to be the trickiest part. Well, not the trickiest part. The next part is going to be the trickiest part, but I'd like to get this just done so it stops giving me a red line. Ooh. Remove these read-onlyness, because theoretically I'm going to have to modify that later on. I definitely don't want this value or ID read-only. And so then what we got to go through and do, first ancestors this. Now if I was to run this regularly with this ancestors this, I can't do something. There's nothing like super dot ancestors, is there? Is missing an implement. So if it's missing an implementation, how come it works over on D3 hierarchy node, no datum count? Structure access. So it's entirely possible that those methods, as part of an interface, is treated like an actual interface, and those things are assigned at runtime once we build a hierarchy with constructor, export function, data hierarchy. Except that it isn't. Unless I'm missing something. Node datum. Hierarchy node datum. heck is this? Yeah, that ain't helpful. All right. Do we have any hints from this file? Hierarchy. I mean, theoretically, I could just re-implement the entire D3 hierarchy from scratch inside of my own project, but that just seems like a stupid amount of work to get around a limitation of TypeScript. And like theoretically, it shouldn't be a limit. I'm guessing it's not an actual limitation of TypeScript. I'm guessing it's just a limitation of my own skills, but while I'm trying to do that, try and get something different going, because it is getting kind of boring here. All right, let's try getting Zig installed on this computer that I'm running on the. All right, back to our little diagram. On the computer running this thing, running the streaming, I can also do a little bit of post-processing here. So what I'm thinking is to try and get, first I want to get Zig running, because from there I can start using a program called, to maybe see if I can generate a little bit of music. This would be, it'd be very interesting. And then from there I'd also, but to do that I need to get Zig installed, so I'd like to take a little bit of a side adventure to do that before I really try and tackle this other thing. Before I try and figure out how TypeScript types work. All right, Zig, my beloved. All right. Glorious. Oh, yeah, I do have my logo here. All right, so it looks like that file gets deleted. However, last time I tried this, it did. explode my computer slightly, so I'm a little bit cautious about that. Specifically this thing. Permissions. Weird. Fun. Alright, so we're in stream. Let me get this straight. Ubuntu comes with some bootleg version of Python installed, but not Git. You know what? I suppose Python is a little bit more of a user application than an actual what's the name application. And my audio isn't getting messed up. Okay, good. Alright. Yeah, I suppose Git is a little bit too specialized for everyone, whereas what with the whole average familiarity nonsense, might be reasonable to assume that the people who make Ubuntu distributions probably assume everyone uses Python. Although, let's be honest, if you're using Linux, you've probably used some version of Python in the past. I'll leave that there for a second. Might even drop this thing in. All right, so with that being said, we can go back to our original purpose, installing Git. Okay, we do have Git installed now. I mean, it's a clone, man. You don't need a username to clone. Why? Okay, firstly, that's not how Linux is spelled. That makes sense. Okay. All right. Ah, give me just one moment. I'm gonna turn on my audio so it might cause some feedback. Okay, let's try this. Audio output capture. How about audio input? Hmm. Looks like my volume's still been really low this whole time. Catchy. uh, I did not realize that was that easy. Let's see. Let me set it at a very low volume. Maybe just have it play in the background. No, it's not best practice, but it's yeah. No, that's kind of a bad clip to be recording. Anywho, oh yeah, that's some music on that. That's a really neat program because you can just create audio from your Linux random devices. Now, back to the primary programming, we could say. Regular assigned programming. What we gotta do, figure out how to get this working, which I suppose could just go with the easiest option around. Say that, let's do ancestors this. I'll leave it unimplemented. Okay, so then where the heck are these interfaces coming from? If this is like an abstract class, then it should be at least somewhere we can find it. Each interface. So it's got all this stuff. Function hierarchy. But I see literally no place where this can be. Am I stupid? And also, am I on mute? Because I've got my audio playing full and I can't hear myself. One, two, three, 1, 2, 3, 1, 2, 3. Let me just go do something real quick.